Theoretical recap. A C/CD pipeline, continuous integration, continuous delivery, is an automated sequence of steps that takes source code from a developer's commit all the way to a production deployment. In a standard DevOps pipeline, the typical stages are code commit, build, automated tests, artifact storage, deployment to staging, deployment to production. DevSecOps extends this by embedding security checks at every stage rather than treating security as a final gate. The three pillars you must keep in mind are SAST, static application security testing, which analyzes source code before it runs to catch vulnerabilities early, DAST, dynamic application security testing, which attacks a running application to find runtime vulnerabilities, and SCA, software composition analysis, which scans third-party libraries and dependencies for known CVEs. A common beginner mistake is placing all security checks at the end of the pipeline. This is the security as a bolt-on anti-pattern. Another frequent error is forgetting to protect secrets, API keys, database credentials, inside the pipeline itself using a secrets manager or environment variables. Mini example. Imagine a basic pipeline for a blog app. You add a SAST scan, for example semgrep, right after the build step, an SCA scan, for example, a WASP dependency check, before artifact packaging, and a DAST scan, for example a WASP zap, against the staging environment before production deployment. Each security gate can block the pipeline if a critical finding is detected. This is the mental model you will now apply to a more complex, realistic context. Workshop brief. In the previous workshop, you placed security checks into an imaginary generic pipeline. This workshop pushes that exercise further. You must now adapt a secure C/CD pipeline to a specific, realistic domain, an e-commerce platform. The business context matters here. An e-commerce application handles payment data, user authentication, product inventory, order management, and third-party integrations, payment gateways, shipping APIs. Each of these components carries specific security risks that must be reflected in how and where you place your security controls inside the pipeline. Your starting point is the following simplified pipeline skeleton: code commit, dependency install, build, unit tests, package, deploy to staging, deploy to production. Your job is to enrich this skeleton by identifying which security checks belong at which stage, justifying each placement based on the CIA triad: confidentiality, integrity, availability, and the specific threats an e-commerce platform faces. You are not just copying a generic template, you are making deliberate, argued decisions. Step 1. Threat identification for e-commerce. Begin by listing the main threats specific to an e-commerce application. Think about what assets are at stake: payment card data, user credentials, order history, admin interfaces, third-party API tokens, and which threat categories from your previous lessons apply: injection, broken authentication, access control failures, sensitive data exposure, CSRF, insecure dependencies, etc. Produce a short written inventory. For each asset or component, name at least one realistic threat. This step forces you to think like an attacker before thinking like a pipeline architect. Step 2. Annotated pipeline design. Using your threat inventory, redesign the pipeline skeleton by inserting security steps. For each security step you add, you must specify A. The name and type of the check: SAST, DAST, DAST, SCA, secret scanning, container image scanning, compliance check, etc. B. The exact stage in the pipeline where it is placed. C. The specific threat or risk it addresses in the e-commerce context. D. What happens if the check fails? Does the pipeline stop? Does it produce a warning? Or does it require a manual approval gate? Present your annotated pipeline as a structured list or a simple diagram with written annotations. There is no single correct answer, but every choice must be justified. Step 3. E-commerce specific scenarios. Your pipeline must address 3 mandatory scenarios that are specific to e-commerce and that you must handle explicitly. Scenario A. A developer accidentally commits a Stripe API secret key into the repository. Where in your pipeline does this get caught? How? And what is the automated response? Scenario B. A new version of a popular Node.js payment library is added as a dependency. It contains a known CVE rated 9.1, critical. How does your pipeline detect this? At which stage? And what is the decision, logic, block, warn, escalate? Scenario C. A new promotional discount feature is deployed to staging. A DAST scan reveals that the discount coupon endpoint is vulnerable to a parameter tampering attack that allows arbitrary price manipulation. What does your pipeline do with this finding before production deployment is allowed? For each scenario, write a short paragraph, 5 to 10 sentences, explaining the pipeline's behavior and your design rationale. Step 4. Reflection and trade-offs. No pipeline design is perfect. Every security gate adds time and complexity to the delivery process. In a final reflection section, minimum 150 words, address the following. What trade-offs did you make between security thoroughness and pipeline speed? Are there any threats specific to e-commerce that your pipeline does not fully cover? And why did you accept that gap? If you had to prioritize only 3 security checks in your pipeline due to resource constraints, which 3 would you keep and why? This reflection section is where your analytical and critical thinking are assessed. Be honest and precise rather than trying to appear comprehensive. Deliverable format. Your submission must be a single structured document, PDF, Markdown, or a well-formatted text file, containing 1. Your threat inventory, 2. Your annotated pipeline design, 3. Your 3 scenario responses, and 4. Your reflection section. Diagrams are welcome but not mandatory. Clarity of reasoning matters more than visual polish. Reread your document before submitting. Every security check must have a justification tied to a specific e-commerce risk, not a generic statement.